My name is Chuanmin Hu. I'm a professor and optical oceanographer at the University of South Florida College of Marine Science. I use light to study the ocean.
Dr. Hu can tell what is in the water simply by looking at a satellite picture based on how the water is reflecting light. He's using this technique to track oil for sea image. He says he uses 4 methods.
One is we go to the field, measure things right away. For example, light. So how light penetrates the ocean, how light gets reflected or scattered by the ocean, we have to measure right there. And the other is we collect water sample and analyze what's in the water and see how many particles, how many phytoplankton cells, and how much dissolved organic matter are in the water sample. Number 3 is remote sensing. The satellites collect data, but we download the data and process the data using either standard algorithms or our own algorithms to process the data, to produce imagery and other data products. And number 4 is the synthesis. Okay? We not only use our own data, we use data collected by other groups. Okay? So we put all data together to see a larger picture.
Hu had been using these methods for other applications, like water quality, so he was prepared to hit the ground running when the Deepwater Horizon spill occurred.
Then I got involved in this spill. I look at the imagery every day, okay, almost day and night, because people need this information in time to respond, to know where to go, do some mitigation, okay, collect the oil or burn it. And the physical modelers need this information to drive their model, to initialize their model and to predict where the oil moved, to validate their model.
5 years after the spill, Sea Image is shifting their focus to predicting long-term impacts. One way they're doing this is to look back at the IXTOC spill, which occurred in 1979. Hu and his students are mapping where that oil went. Shaojie Sun, a PhD student in Hu's lab, explained why this is important information for other Sea Image scientists.
A surface trajectory would give important implication where the deposition is and would help provide information of the long-term effect of the Deepwater Horizon oil spill.
In short, Hu's maps will tell scientists where to collect sediment samples.
This is our IXTOC result. It's a beautiful image.
Hu and his students can see where surface oil goes, but they wish they could tell more from their satellite images.
The largest challenge is bother me a lot if there's no accurate or well-accepted ways to measure oil thickness in the field.
If you were given a task to go to the field to measure the thickness of a very thin film on the ocean surface on the wavy sea, how do you measure this? And that's the most challenge for now, for me, in Sea Image.
Despite limitations, they're creating products that are available for anyone to look at and use.
So I serve the products online in near real time, so everybody can use. There's no password, because this is open data.
Letting anyone use their products encourages progress in oil spill response, and that is Hu's overall goal.
If we respond in time, faster than before, we can save this much money, or save this much effort, or to the extreme, we save this much life. Then it's a huge value for the society.